So if we take a step back, the traditional dev CI workflow that we use in this kind of post-monolith age is that we code and run our unit tests locally. That is before we push to GitHub or GitLab. But we really only run our integration tests and end-to-end tests in CI. We usually have a separate configuration for our local development environment, which is often a simplified or partial setup compared to the full stack. You may have maybe a Docker Compose setup where you treat certain services as remote, or you may even use the staging instance for several of the services. Problems with this are that while the coding, seeing your feedback locally and running unit test workflow is quite fast, anything past that requires a lot of time. So if something breaks in CI, it takes a while for that to be spun up, the images to be built and so forth. And it's usually getting up for a cup of coffee and checking back kind of timescales we're talking about there. And also just being able to achieve integration and end-to-end tests, writing those things is not trivial. You would have to spin up the stack, make sure that everything is on the right version, and so forth. And actually what we see a lot of companies doing is that they really only run integration or end-to-end tests against a staging instance after things are merged to the main branch, or at any rate, the feedback loops are very, very slow, and that kind of limits the amount of stuff that we can catch in this nice, tight, pre-commit feedback loop. And in addition to that, the fact that the development environment that we use locally is different in subtle ways from the full CI or prod environment leads to subtle errors that come up down the line. These kind of classical works on my machine problems that don't come up, that wouldn't come up if you had a production-like environment from the get-go. If something goes wrong, let's say a test breaks in CI, you have to go back, fix the code, push again, and get another cup of coffee, and wait for the next rinse and repeat. And not to mention that writing new integration tests or changing the structure of your pipeline, then you have to go through the whole CI slow feedback loop cycle to debug your new tests. Also, the time you invest in your CI pipelines doesn't really improve your pre-commit workflow at all. Your CI pipelines understand that first you have to build, then you have to deploy, and then the test comes after that. And there's a lot of sequential dependency logic that's encoded in your CI pipelines that's not really available for you outside of that context, which is kind of a waste. And finally, CI pipelines usually aren't portable between CI systems. Like your Circle CI config is not completely equivalent to your Jenkins config or whatever. So there's a bit of vendor lock-in inherently there. Not the best traditional CI systems. They're great at what they do, but they're sort of somewhat limited by the scope of what they're trying to tackle. So our approach is, to put it bluntly, configure once and run anywhere. With Garden, you write a brief configuration file next to each of your services. That basically, it lives next to a Docker file and your source code. And you describe to Garden for each service how it's built, how it's tested, and how it's deployed. So here you see on the right-hand side the services that come out of this module, the ports that it has, and so forth. And on the bottom side, you see that to unit test this service, you do this, to integration test it, you do that. In addition, each of these steps, whether it is building or deploying or testing, can describe dependencies. So for example, the integration test here on the bottom, as you can see, has a dependency on API, which is another service in the same project. But this means that Garden knows that in order to run the integration tests for the Vault service, the API service has to be up and running and up to date. And the thing is, like, this is the kind of dependency-aware pipelining that you usually only have access to in your CI system. But if you have it set up in Garden, you have access to the same power in your pre-commit workflows. And because Garden has access to how to build, deploy, test, database, migrate anything from the get-go. It's able to also spin up a full production-like instance of your stack before you commit, and it can do things in exactly the same way in CI. So the second half of this really is that you can have several environments set up. You can have a development environment that's separate from your CI environment. You can have a local environment. You can have a development environment that's shared across all developers in your team, which may or may not be the same cluster as you use for CI. You generate a separate namespace for each developer or for each CI run, and then you use environment variables, or if you're using Garden Enterprise, you can use secrets that are automatically piped in for Garden Enterprise to make your config more dynamic and to generate the namespaces and so forth that you need. Another nice side effect of this is that it becomes really easy to deploy a preview instance of your stack for QA. So for example, with your PR, you might automatically want to run a workflow that spins up an instance of the stack so that whoever's doing the code review can not only see that the test passed, but can also kind of click through things and see how things look. And the reason why this is feasible is because, again, Garden knows how everything fits together, so it can trivially spin things up and tear them down. So here on the left-hand side, we have a contrived Circle CI configuration example of how to deploy, build, and test a particular project. You have to build the API service, build the vote service, deploy, and then test. And you see here, there's a lot of valuable information that's encoded in here. Like this has to happen before that. Deploys depend on builds, tests depend on deploys. And because it's siloed in the CI configuration and not being used by a tool that's available to you in both phases, you kind of miss out on the benefits that Garden would bring you, where you simply configure your Garden project. And then you have access to the full power of your CI-like, production-like environment during development. And also as a nice freebie, your CI pipeline essentially just becomes check out the repo, configure your connection to a Kubernetes cluster, and just run Garden test. And Garden test figures out building, deploying, testing, and so forth. And that also means that by the time you have reached CI, you can be running integration tests as you go. And because your pre-commit environment is basically exactly the same as the CI environment, of course it depends on how you set things up, you can usually be pretty confident that your tests are going to pass when they actually hit CI. And if something goes wrong, you just go back, change the code, run the integration test from your local machine, and that should usually make them work in CI. Yes, and here's a little diagram that shows how this works. If you share your dev cluster with your CI, your development flow and your CI pipelines can share a Docker build cache and a test cache. And because Garden understands the dependency structure of your project, it's able to do some smart caching, figure out, oh, well, this module has already been built and this test has already been run at this version, so we don't need to rerun that. And this kind of shared cache really starts being able to speed things up a lot when you have a lot of services. And the general rule is the more complicated your stack is, the more of a speed up you can get through Garden, because again, Garden can figure out what work is unnecessary given the changes that you've just made. And again, like I mentioned earlier, because you can run your integration tests as you go, even before you commit, you don't have to wait for the CI pipeline to rerun to see if your fixes actually resolve the issues that were surfaced by the tests. So I'm just going to hop into a brief demo here. Let me see. There we go. Can you see this, guys?
Yeah, looks good.
All right. So I have a contrived little project here. This is where the snippets from the slides earlier came from. It's a project with a few microservices. We have let me actually just open up the dashboard here to show you how this works. We have an API service that is pinged by a front-end service that votes for cats or dogs. That's then put into Redis. The Redis queue is drained by the JWorker service. And the JWorker service inserts the votes into Postgres, and then the votes are read from Postgres into the result service, which shows you the cats versus dogs votes. Anyway, So this is not a super complicated project. We only have 6 services here, but once you think about how to spin up the entire stack, things start to get a little bit more complicated. To deploy things, you need to build the modules first, and if there's a sequence to things, for example, for the JWorker service to be up, it has to be able to connect to Redis. So Redis has to be up for the connection to work and so forth. And once you add database migrations to the mix, for example, to set up the schema, to seed the database with test data, things get a little bit more complicated still. And then as you add tests on top of that as well, you see it balloons quite a bit. But it's not scary when you're using Garden for this, because you just write down in a simple way. Let's just look at this here. What depends on what? The unit tests for the Vault service only depend on the Vault service being built. The integration tests also depend on the API service being built, and so forth. So from these simple dependency declarations, Garden assembles a directed acyclic dependency graph from your whole system, and you could just tell Garden to test your whole stack. So it's forced to repeat it here, and it will do only the work that's needed to test the system. And you can see that it's not rebuilding modules that haven't changed, that is services that haven't changed, but it will also intelligently figure out when things have to be retested. So let's just wait for this to finish here. And then I'm going to go ahead and break something and show you how we can actually break an integration test, see that the integration test was broken before we push to a remote branch, and then fix it and do the whole thing from my laptop. So here we have the integration test. There it is, integration test for the API, for the Vault service. So the Vault service also has unit tests, but we're going to break the integration test. And the way we're going to do that, we're going to go into this API service. So the integration test for the Vault service expects to get a 200 status from this endpoint here. It's returning 200 now, so that should be fine. However, if we change this to 300, that's wrong. So without Garden, how would we figure this out? If I were to rerun the unit tests only for the Vault service, they would all be fine. So would the unit test for the API service, because this bug only surfaces when you test the interaction between the two services. That is, the API service, as far as it's concerned, is still working correctly, but the Vault service is not getting what it expects from the API service. So this is a classic example of something that you would only see surfacing in CI. And then you got to fix it, push something that you hope fixes the regression. You wait 20 minutes, half an hour, whatever it is, and you try again. Whereas with Garden, I can just run Garden test. And what this is going to do is it will sync the changed sources into the Kubernetes cluster, where the module that is the service will be rebuilt inside the cluster. It will deploy an updated version of the API service, and then it will start a pod to run the integration test for the Vault service, which will fail. And all of this complicated machinery is abstracted away from you. And you will note that I actually don't have Docker or Kubernetes running on my laptop right now. So imagine if you had a large stack, maybe 30 services or whatever. Even if you have a beefy laptop, it's not really going to be able to cope with all this stuff. And the thing is, servers are good at being servers, and laptops are not. So Kubernetes is actually a great platform for this kind of development flow, provided that you have the right tooling on top of it to kind of sugar away kind of the gnarly machinery and the nuts and bolts below it. So Garden really is just talking to Kubernetes via a bunch of API calls and syncs to make all this happen. So you see here, it rebuilt the API service. It's going to redeploy that. And this is going to break the integration test for Vault, as we see. And you can see that right here. So all we had to do was run this single Garden command. We didn't have to rebuild every Docker image in the stack. We didn't have to we didn't have to figure out, oh wait, I changed the API service. What depends on that? It's really easy to forget that the integration test for the vote service actually depends on the API service. But if you just declare your dependencies with these Garden configs, Garden just takes care of figuring it out. You explain it once and the machine takes care of the rest. And now, just an added bonus to show off the smart caching functionality in Garden. I'm going to fix it again. You see, I changed the status from 300 to 200 again, which is correct. And I'm just going to run Garden test again. It does nothing. And you see that the test goes back to green. And the reason it didn't have to run that test is because previously we ran Garden test while everything was working. And Garden has cached in the cluster that at these versions of these services, we've already successfully run the integration tests. So we don't have to do anything because we just did that. And this kind of smart dependency-aware caching really comes into its own when you have a lot of services. The thing is, like, to be able to run integration tests ad hoc like this, I mean, it's potentially a big and very expensive operation. It really helps to do some smart caching, just to make the whole enterprise a little bit more affordable in terms of time. And again, like the way this project would be integration tested in CI is literally just the same. You would just do Garden test and CI. And this basically means that you only have to maintain one set of configurations. You just do it with Garden, and then you can start thinking of your CI system as simply an executor that runs Garden. You don't have to construct your pipelines there because with Garden, you're setting up with a tool that works everywhere. Again, write once and run everywhere. And so, wait. Just going to go back here. Right, yes. So in summary, what this gives us, if we were to compare this with the old flow here, right, there it is. So in the old flow, really all we could do locally was work with our kind of stripped down, simplified local development environment, which has, again, these subtle and problematic differences from the real thing, and run our unit tests. We could have a really nice development experience there, hot reloading and so forth. But unfortunately, a lot of us are leaning way too heavily on CI and kind of just suffering these slow feedback cycles there, which again, it's not the fault of the CI system. It's just, that's just the way, those are just the limitations of the way those tools approach things. But what we have with Garden, see, is something that's more like this. As we're coding, we can be running unit tests, we can be running integration end-to-end tests. And one thing that I forgot to mention in the demo earlier is that you can deploy services with hot reloading, which means that when you change source files, the changed source files are synced into the running service. So you can get the same kind of live reloading, fast feedback development experience as you're used to, for example, in front-end workflows, without having to strip down your environment and work against a reduced version. But so essentially, you have exactly the same level of power before you commit as you have in your CI system. So we're kind of shifting the power left, so to speak, in this regard. And of course, you may not be you may have an additional set of tests that you don't want to be running in dev all the time. Maybe some of the more expensive end-to-end tests and so forth. But the point is you have access to them all from your local machine. That the CI system isn't kind of fundamentally privileged in terms of what kind of architectural work it can do. And again, you only have to maintain one set of configurations. And yes. So what this gives us, in summary, is a development environment that is production-like. In fact, the differences from production can be as minimal as you can make them. You may want to have a more lightweight database or use kind of simpler, more lightweight versions of certain services in development. But essentially, you can have a development environment that is exactly the same as your CI environment. You completely get rid of the works on my machine type bugs because you're running stuff remotely in an environment that very closely corresponds to what's going on in CI. So that eliminates a gnarly and kind of subtle class of bugs. The full power of your tests is no longer siloed in your CI system, because through Garden, you can run them from anywhere, from your laptop, from your CI system, or whatever. And again, because you can run any part of your test bed as you code, you could be pretty confident that by the time you push your code, you've already been running all the integration tests. So the modules will have been pre-built, that is, the services will have been pre-built, and you can be pretty confident that the test will pass through CI, because they're basically doing exactly the same thing that you've been doing while you're developing. And because you can run these things from your local machine, and because Garden does all this smart caching, it really speeds up the whole thing. You can be getting feedback for your integration tests like in a minute or in seconds, rather than 20 minutes, half an hour, I don't know. And these faster feedback loops really just help us stay in the zone, kind of lowers the frustration quotient a little bit, and helps us develop a little bit more confidently and ship a bit more quickly. Also, writing and debugging integration and end-to-end test cases becomes a lot easier. So let's say you're writing a new integration test case or a new end-to-end test case. As you're writing it, it's so much better to be able to just trigger the test suite from your laptop, see if things work out or not, instead of having to go through the whole pushing to a branch, rinse, repeat, wait for 20 minutes, which really ends up disincentivizing us from writing integration and end-to-end tests. The thing is, like, things that are expensive and painful to do, we do less of them. And that's really a shame, because integration and end-to-end tests can be really, really useful tools when you're working on distributed systems. And the final point I wanted to make on this slide is portability. So Garden is an open source command line tool that just uses these YAML files that you place next to your services, and that's completely portable. You can run Garden test from your Circle CI, you can run it from any other CI, which has this nice side effect of not locking you into any particular CI vendor. And speaking of cloud providers, I showed you these environment configurations earlier. It's very easy to, for example, have your CI environment be on AWS and your development environment being on GKE and so forth. Just point Garden at a cluster and Garden will figure out what needs to be done. So yeah, again, like portable, reusable, and the same power in development as in CI. So yeah, that's about it. I think we'd just like to open it up to some questions and answers.
Yeah. So we have first a question that came up in the chat, and I'm just going to read it out loud and also read the answer that Aethor typed, just so that anyone who watches the recording can follow that one easily. So the question was, does the caching use the source code hash to distinguish versions or something else? And the answer to that one is yes, it does. And it also includes the hash of the modules it depends on in the calculation. Mm-hmm. So changing an upstream module will give the downstream module a new hash as well. And it also tries to be smart about what to include in the calculation. So it'll exclude things you git ignore, Garden ignore, irrelevant configuration, and other source files that are not included in the module that's actually built and deployed.
Yeah, and I'll add to that like Garden is very conservative about what it caches. So if there is any doubt, if there's any logical doubt about whether something counts as cached, we will rather redo the work. But in a lot of cases, just based on the dependency structure, that coarse-grained dependency structure, we can actually figure out that we can skip quite a lot of unnecessary work. And especially as your systems grow bigger, the savings grow.
All right, excellent. So I'm going to switch over to the questions that came in beforehand. So give me just a second to get those pulled up. Before I do that, I want to say thanks so much for the presentation and the demo. I thought it was awesome. And so great job. All right, looking now at some of the questions that came in beforehand. So if something passes, how do I push or promote the images that I have?
Right. So AC, maybe you want to take that one. You're the CD man.
Yeah, so first of all, we have a Garden command that allows you to push or publish images. And in that command, that command will use the module version. You can also reference module versions in Garden config files via template strings. So if you have, you can define what we call like local exec tasks or execution tasks, where you can reference basically with a template system the version of any given module, and you can do what you need to do, run any commands. And finally, what we see a lot of users do, this is kind of a power user trick, but Garden has, the CLI tool has a list of get commands. You can do garden get modules, garden get tasks, and it will turn it like in a fancy CLI output, but you can you can configure the output parameter or the output option, and you can ask Garden to return you these values either as YAML or JSON as well, as opposed to like fancy, terminal strings. And you can use a tool like say JQ to just parse that output and use that any way you want in, whether you're developing locally or CI or what have you. So you can do garden get. So to answer the question concretely, it would be garden get modules dash output equals JSON and pipe that to JQ to, basically get it to any information about all the modules in your current project that's relevant to you. So the shape is roughly, you have your modules, and then to them belong the versions and the version strings and so on and so forth. So you can basically get at all that like underlying data that you need through these commands.
Yeah, and I would say that, like, as a more general point, Garden does its best to be a good Unix citizen, and they can produce kind of machine readable output for almost all of its commands. So it's also very suitable for building your own tooling on top of, if you have any cool ideas of how to integrate Garden into other kinds of workflows. So yeah.
Yeah.
All right, cool. So a couple more questions that just came in the chat. So we'll go to those next. So first question is, how can you have different Garden YAML files with different scopes, maybe for two different test suites, such as functional versus performance?
Right. So if you want to have, so if the way I understood the question, like, how do you have different scope tests for a given service?
Yeah, and the question is in the chat tab in live stream, if you want to double check it.
Yeah,
just
let me just double check that here. Check the tab.
Yeah, so I think the point.
Yeah, exactly. So just to yes, in that case, like we did with the unit and integration tests earlier, what you basically do is you set up different test specs. So you say this is the unit test spec, this is the integration test spec, this is the functional test spec, and then you can run those separately. You can, for example, say Garden test, and then narrow that down to unit test, narrow that down to functional test, and so forth. And if you use the same kind of scope name, yeah, so you can say that test scopes are kind of a built-in part of how Garden organizes its test suites. So
yeah, perhaps you can show the because when you were going through the steps earlier, there's a little lag. So if not everyone caught kind of the YAML config on your screen, but could you
right? I'll just switch back to that.
Yeah.
So here, for example, can you see here?
Yes.
Yeah. So here the unit test. This is the scope here. You can have like a functional test. That's like, I don't know, like functional. And like, what was it? Was it test? Was it name? Is it? Remember?
Yes.
I think so. Yeah. And then you can like only run integration tests. And this will run tests across all services that have the name integ, for example. So you see it skipping the unit tests here.
Yeah, exactly. So like Garden's kind of concerned with like the what and the when, and you tell it the how. So for instance, in this project, it's an npm module. So we're using npm to run and define the task, but this could be Java, this could be anything. At the end of the day, like you tell Garden how to execute these commands, and Garden figures out how they fit into your wider graph of dependencies.
Mm-hmm.
All right, and then there was a second question. It looked like some of the boxes in the stack graph view that you showed during the demo were just integration tests. Is that right?
Let me see. Just gonna check out of here. Sorry, slide party is here. So here, so each of these nodes corresponds to kind of one unit of work. So you see we have a node for the unit test for the API service, unit test for the vault service, and then integration test. So basically, like for each test scope and for each service, you would have one box. And the reason why we have separate boxes for them is that they can have separate dependencies. So for example, the unit test will usually only have a dependency on the parent module, whereas integration tests may have runtime dependencies on like all the services that the parent service has to ping during the execution of the test suite.
Mm-hmm. I see also in the chat that Jon adds a point on tagging and publishing images and mentions that we also have workflows for those. So they are kind of another layer on top of the stack wrap, which allows you to run a sequence of both different Garden commands and basically any given arbitrary.
Oh yeah. Maybe I should check that out real quick.
Yeah, maybe you can show an example. But this is similar to what a CI pipeline would look like. So you can also run these Garden commands in succession. You can have conditional steps. You can have steps that only run if the previous step succeeded, or rather if it failed. And again, run these arbitrary scripts. And this is a case where it's useful to, say build, and then deploy, run your task, and if the task pass, read the output and use that to attack and publish images.
Yeah. So when you do need these kind of more explicitly pipeline-like sort of execution semantics, then workflows are an excellent fit. But again, they're Garden native, and these things can be portable and can travel with you to any CI system of your choice.
All right, great. So another question that had come in was, where are you actually running the tests? Can it get expensive to run all this stuff? And I'll say as an aside, we do know that there are some projects out there using Garden with upwards of 200 different Garden modules, and otherwise, like without Garden, would be extremely expensive to run for every small change. And so anyway, back to the question though, where are you running the tests? And can
so the tests are, and of course it depends on your particular setup, but essentially what you do is you have a Kubernetes cluster for development and for CI, which may or may not be the same cluster. And the tests are basically run, like you run a Garden test and you schedule a pod for each service that needs to be tested. The pod runs the tests and then is terminated. And if you have a cluster that's auto-scaling, like Garden will automatically terminate the test pods after they finish execution. But yeah, I mean, there is a cost associated with having shared development environments. Of course, you can avoid some of the work by cleaning up your namespaces and by having these build caches and so forth. But of course, this is getting into Garden Enterprise a little bit. Garden Enterprise is a paid offering that we have, which is a web application that does add some extra niceness on top of Garden Core. And with Garden Enterprise, you can also set things up so that environments will be automatically cleaned up, for example, at the end of the workday, or when the namespace hasn't been used for a while. So just to make sure that you don't have any dangling resources. But again, it depends on your particular setup. But if you have the right sort of processes around managing your environments, you can keep the cost to a minimum. But I would just say that like our time is expensive and frustration is expensive, and speeding these things up, getting to deliver faster, it's well worth the modest expense of doing this, I would say. And it's not a huge expense at all.
I agree with that. And maybe just one pro tip, since we're kind of on this topic. So you mentioned, so what we generally do is, we have different environments for dev and CI, and in each environment we have namespaces. In dev, one per developer, in CI per test run. But what we like to do in development, because Dr. was showing before, we're running, even doing development integration tests. So we have a Postgres instance running, which is our database of choice in its development environment, which has a schema that we use during development. But then to make sure we don't mess up things when we run the actual test pod, what we tend to do is we spin up a test pod, say for a given service, and have that create like a unique schema just with some random name in the Postgres database, and run the test against that. So that's kind of partitioned from the rest of the test data, so to speak. So we can create that schema, see it with some test data, do what we need to do to run the test, and then delete the schema afterwards, without having to mess up our the database that we use for day-to-day development work. So that's a pretty nice workflow, and it's worked really well for us, so that we can just kind of, without causing too much trouble, run tests in our own namespaces.
Yeah.
Great.
So, recommend that one.
And so one more question that's come in, and feel free to keep asking. We're here for the hour if there are more questions. But the last question I have here is, does this more or less work the same way if I have multiple repos? What's the sort of approach with multiple repos.
Yes, it does. Let me see if I could just actually. So if you have multiple repositories, what Garden can do is you have a kind of top-level project repository that has the project configuration, which includes things like what cluster to connect to, what environments you're using, and then it can reference other repositories that have source code and also maybe other Garden modules. And so from this kind of central entry point, you can assemble a project from multiple repos. There are several ways to go about this, but this works seamlessly and it's being used by a lot of our users. So essentially, kind of remote sources and remote modules are kind of a fundamental built-in concept in Garden. So that's kind of how that works. And Garden kind of assembles a graph of services, tests, and so forth from all of the pieces that are assembled here.